Hey you guys, this is Mr. Sal. This is a question from a student that I thought I should go over. It was going to be too long to put into an email or a response, so this is with all the virus stuff going around, so hopefully you guys are staying safe, staying clean, washing your hands, doing the social distancing thing. We want you guys to be healthy, and your families too, so just be careful out there, alright? Here we go. Number 6. Circles of radius 4 with centers at 4, 0, and 0, 4 overlap in the shaded region shown in the figure. Find the area of the shaded region in terms of pi. So no decimals on this one. We should have all of our answers in terms of pi. Now the first thing I'm going to do with this shape is to look at the square, which is right here, right? Now I'm going to move that out here, and what I want to do is find the area of this square. Now, since it goes to the points 4, 0, and 0, 4, we know it's a square with lengths of 4, so the area of the square is 4 by 4, 4 times 4, which would be 16 square units. Now next what I'm going to do is I'm going to look at this, and hopefully you traced that better than I did, but I'm not just looking at the line here. Again, I'm looking for area, right? So I'm really looking at this piece right here. So I'm going to take that piece and I'm going to kind of separate it down here. Now notice I'm not really focusing on this line right here, right? I'm not worried about that line right now. We got to break this up into separate parts. So I've zoomed down a little bit so we can really see what this is. And well, what I have here in terms of area, and we may not notice it right now, but this is a quarter of a circle. So I'm looking at this shape, right? And what we see is that this is a quarter of a circle, and it's this piece that's shaded right here, right? So again, I'm ignoring that circle, but how do I find the area of that shaded region? Well, I would treat it as a full circle, which would be pi times the radius times the radius. But since it's only a quarter of a circle, I'm going to have to divide that by 4. And we do know the radius in this one, right, because it's part of that square, right? This was inside the square. And the square had a side length of 4, so I can take the radius, or the radii, and replace those with 4 units. Now what happens right here, I mean, you could type this into the calculator, and most calculators will give you the answer in terms of pi, but the 4's are going to cancel it right there, is what I would notice first. And what am I left with? Well, I'm left with 4 pi on that. Now you may be wondering how this is going to be helpful. Well, what I'm going to do is I'm going to take the square. I'm going to take the square I drew up there, and I've drawn that red line in that square, which is that quarter circle part. And what I want to focus on actually is this empty area right here, right, which would be this part. And the reason I want to do that is because that area, the green area right there that I have shaded in, is being removed as part of the area of the square, right? What we're asking for in this problem is the purple shaded area, which I put into that now. But we also have 2 of those shaded green areas. So in actuality, once I find the area of one of these green shaded areas, I'm going to multiply it by 2, and I'm going to subtract it from the area of the square, which is just 16 square units. So the 4 pi, which is the area of the quarter circle, is actually going to help us to figure out the area of this missing piece right here. So let me go ahead and shade that in green so we can see the corresponding parts on that right there, right? So in terms of the square, the whole thing is 16, right? So we got 16 square units for the square. But then, if I wanted the area of that green shaded region, I would have to subtract the area of that quarter circle, which is 4 pi. And this would be the area of the green section. Now, going back to the original figure up here, right? We got the area of the square. And if we wanted the area of the purple, all we really need to do is subtract the areas of the two green parts. And we just figured out what that area is. It's 16 minus 4 pi. So I'm going to show my work down here for that. So again, I start with the area of the square. I'm going to subtract the area of the green, which is 16 minus 4 pi. But don't forget, we have two of those, so I need to put two of them in parentheses. Now you could have said, well, I'm going to subtract it once, and then you could have subtracted it a second time over here, but I'm going to use the distributive property just to make this a little bit easier. So we go back to one of our previous units with distribution, right? I'm going to distribute the 2, but this is not just 2 on this, okay? This is actually a negative 2 that I'm distributing into the parentheses. So what that means is I actually have negative 2 times 16. And that's the first distribution, which would give us negative 32. And then the second distribution would be negative 2 times negative 4 pi. Now we're keeping this in terms of pi, so we want the pi there. Negative 2 times negative 4 is positive 8 pi's. So right now I have 16 minus 32 plus 8 pi. And this goes back to combining like terms. And the only two like terms we have in this expression is 16 and negative 32, which would combine to be negative 16. So I end up with negative 16 plus 8 pi. Now I'm going to point this out in the answer key for this. We saw that it was actually written as 8 pi, which is positive, right? As a term, it shows positive with the plus sign right there. And then it was minus 16 because the 16 term is negative. So, well, either one of these works, okay? And we talked about that in class. It doesn't matter which order these are in. It's okay either way. But that is actually the area that's shaded up here in purple right there. This would be the purple shaded area. Alright, I hope that was helpful for you guys. Thanks for watching. This was a pretty challenging problem. That's good. We want you guys to be challenged. I hope you feel good about finding these areas and kind of breaking it down into these separate, more manageable, smaller parts of the problem. That's the key to mathematics. If you guys can do that, you'll do very well.